Now we're moving on to talking about other special quadrilateral. So let's take a look at, well, let me backtrack actually. Trapezoid. What do you know about a trapezoid? What do you know about a trapezoid? Trapezoid is still quadrilateral, so it still has 4 sides. And this, there it goes. Here is Joe Schmo trapezoid. Based on the markings therein, how would you define a trapezoid? Is it, here's a good place to start, is it a parallelogram? Yes or no? No, it is not. Definition of a parallelogram is that it has 2 pairs of opposite parallel sides. Looking at the screen, I only have 1 pair of opposite parallel sides. Okay, so a trapezoid is a quadrilateral with exactly 1 pair of opposite parallel sides. In this trapezoid, the bases would be which sides, do you think? Which sides do you think are going to be the bases? These here, or the ones that are going like this? Which ones? The ones going like this. Give me a vocabulary word for this. Parallel, yes. All right, so the bases of a trapezoid are the parallel sides, whereas the legs are the other sides, or the non-parallel sides. So this is a This is a base. This is a base. Leg, leg. The angles sharing a base of the trapezoid are base angles. So we refer to these as a pair of base angles. And notice that the trapezoid will therefore have 2 pairs of base angles. These 2 down here and these 2 are also a pair of base angles. Now we've seen the term isosceles before. When we talked about isosceles triangle, what made an isosceles triangle isosceles? What do you remember about your vocabulary? Isosceles, great. Has 2 congruent sides. So I'd hope that you realize that if I'm talking about an isosceles trapezoid, it's going to have 2 congruent sides. Which sides do you think are going to be congruent? The legs or the bases? The legs, yes. So let's take a look at an isosceles trapezoid. I will bring the screen back if you're not done getting from the screen that you need. Don't panic. Right here, for your viewing pleasure, is Mr. Isosceles Triangle. What do you notice about it? Look at the measurements that I've taken of it. What do you notice about this isosceles trapezoid? Use some vocabulary if you can. Look at what I've measured. I've measured BD and CA. What are BD and CA of this trapezoid? What are they? I heard it. They're the diagonals. And what do you notice about those diagonals? No matter how I wiggle this trapezoid, they are congruent. So in your notes, there's probably a blank there for the diagonals of an isosceles trapezoid are congruent. Notice what else I measured. I measured angle BAD, angle CDA, angle ABC, and angle BCD. So basically, I measured the 4 angles of the trapezoid. Because this is an isosceles trapezoid, what do you notice? What's congruent? The base angles. There we go. So coming back to our notes, the base angles are congruent and the diagonals are congruent. And we have from the screen what we need. Let's take a look at some examples. In problem 1, I have that angle S is 75. I'm asked for all the other angles. So pick an angle. Give me its measure. One person, please. Grace. Angle R is 75. Yes, sir.
Angle U is 105?
Yes. Measure of angle U and the measure of angle T. Yes. They will both equal 105. There is your turn for problem 1. I will give you a moment to go through that within your group. I want to finish out this screen first, though. Problem 2. I have this isosceles triangle. And I'm trying to find the angles X and Y. Which angle do you think we'll find first? Which angle do you think we'll find first in problem 2? In general, myself personally, I like to go alphabetically as well. However, looking at this problem, I would be more inclined to look at the big picture, triangle ABC. Remember that the instructions told us that this is an isosceles triangle, and I know it was a while ago and it was before a break and stuff has started to fall out of your brain. Let's stuff it back in there. Remember that in an isosceles triangle, there's not just 2 sides that are congruent. There's 2 angles that are congruent. And of course, I've said it many, many times, what do you know about the 3 angles of a triangle that is tattooed on your soul? They add up to 180. So, I could start by taking 180 minus this 32 that they gave me, and I get 148. And what am I doing with that 148? Dividing it by 2, and that'll give me angle Y. So Y equals 148 divided by 2, which is 74. And now that we know what Y is, X is very easy for us to find. What is it, Austin? It's 106. Before I say go forth within your groups and complete your turn for problem 1, are there any questions on how we found either angle X or angle Y? Yes, ma'am. Okay. Remember up here that we noticed that angles R and U were supplementary in this trapezoid. Notice this is a trapezoid down here also. The X and the Y will also be supplementary. Okay, another way to think about it, let's come back to this diagram. See these parallel lines? Notice that this angle R and this angle U are same side interior angles. Remember from way back in chapter 3, that makes them supplementary. All right, so you have your turn for problem 1 to be working on within your groups. part B, notice it's referring you back to problem 1 where we had trapezoid RSTU. Right, based on what I am seeing and hearing, you're ready to compare your answers to mine. And there they are. And please, if there's something that I need to clarify, reiterate, state a different way. Part B. All right, so remember the point that I made to Helena, that even if the trapezoid isn't isosceles, let me get a blank screen. Even if I'm looking at, as I said earlier, Mr. Joe Schmo trapezoid, these lines are still going to be parallel. And that makes these two angles, let's call them L and M. Do you see that they are inside the two parallel lines on the same side of the transversal? That's why they would be supplementary. Any further clarification required over here? Good? We're still getting from it what we need. Okay, last chapter, way back in chapter 5, we talked about the mid-segments of a triangle. I'm going to refresh your memory on that. The mid-segment of a triangle, remember, was formed by connecting the midpoints of two sides. Remember that the mid-segment of a triangle was parallel to the third side. Remember that the mid-segment of a triangle was half the length of the third side. Trapezoid will also have a mid-segment. Visually, this is what we're looking at. Again, it doesn't have to be an isosceles trapezoid. It can be Joe Schmo trapezoid. And once again, what I would hope that you'd be realizing is that that mid-segment is parallel to the bases. And the property dealing with its length isn't quite as obvious to us for trapezoids as it was with triangles, so I'm just kind of giving it to you. Its length is the average of the bases. Okay, so when we were talking about triangles, it was just half of that one other side. Now it's half of the sum of two sides. So in problem 3, if this was just numbers, you guys wouldn't have a darn problem with it. If these were just numbers, and I was asking you to find the length of the mid-segment, you would have no problem adding those two sides together, dividing it by 2, and finding the length of it. But because there's algebra involved, there's a little bit of hesitation. And let me refresh your memory on how we dealt with those algebraic expressions when it was triangle. You may recall, especially those of you that ended up having to go back and do the skill quiz for mid-segments, you may recall my reiterating to you, you double the mid-segment and then set it equal to the third side. So by the same token here, what we're going to do is double the mid-segment and then set it equal to the sum of the bases. Oh, I skipped a blank up here. Sorry about that. The mid-segment of a trapezoid is the segment whose endpoints are midpoints of the legs. Okay, so coming back to how we set up this equation for problem 3, as I indicated in this kind of formula that I hope you can work with on your turn and in your homework, double the mid-segment. So 4x plus 20 equals, does it look better on your paper than it does on my screen? Is that a plus or a minus? It's a minus. From here, algebra is a cakewalk to solve for x. Combining my like terms, getting my x's together, getting my numbers together, and x is 7. We okay? Did I do my math? We're good? Okay. Take a moment, work through the your turn problem 3. All right, ladies and gentlemen, it sounds like we're ready. So let's resume. In part A, I think most of you had no difficulty setting up the equation and solving it. So we would have 4x plus 22 when we double the mid-segment equals 10 plus 8x minus 12. And save me a couple of moments of work. What was x? X equals 6. Can I get another island to concur? Yes. Okay. So, the instructions, however, for part A didn't just ask us for the value of x. It was also asking for the length of mn. So make sure that you pay attention to whether they're asking that of you in your homework tonight. All right, so mn is 23. Thank you. In part B, some of you already heard me talking about it. How many mid-segments will a trapezoid, or no, let's answer it in the order that it's asked. How many mid-segments can a triangle have? 3, whereas a trapezoid can have only 1. Good. Any questions on this your turn problem 3? Okay, the last, how would you define a kite? Well, let's keep it geometric, please. Does not have 4 congruent sides. It has 2 pairs of congruent sides, and it's very important that we indicate in our definition that it is a quadrilateral with 2 pairs of, it's thinking, consecutive congruent sides. To clarify what I mean by that, remember that in a parallelogram, it also has 2 pairs of congruent sides. However, the congruent sides are opposite sides, whereas in a kite, the congruent sides are next to each other. They're consecutive sides. Okay, so I think I've already given it away, but just so that I'm making sure we're all on the same page, is a kite a parallelogram? No. Parallelogram has 2 pairs of opposite congruent sides. Kite has 2 pairs of consecutive congruent sides. It is not a parallelogram. All right, so vertex angles, let's clarify some vocabulary regarding kites. badly drawn. Laughing at me. The vertex angles of a kite are the angles formed by the congruent sides. So this is a vertex angle, and this is a vertex angle. Whereas the non-vertex angles are the other two angles. And once again, let's take a look at a kite. Yeah, okay, I made this for a... Oh. I made this for a curriculum night a few years ago. Anyway, so notice that these are the vertex angles. Are they congruent? Do I notice anything about the vertex angles? Oh, look at them again. Oh, they are not supplementary. They are not a darn thing. How about the non-vertex angles? The non-vertex angles, are they always congruent, or did I just happen to land? Nope. The non-vertex angles are congruent. Angle IMT is formed by the intersecting diagonals. So what would I say is true about the diagonals of a kite? It's a P word. They're perpendicular. Thank you. Notice I have the angles that are formed by the diagonal connecting the vertex angles. Okay, so in plain English, eyes up, please. These two angles that I've measured here are formed by this diagonal connecting the two vertex angles. Okay, so this diagonal connecting the vertex angles is doing what to the vertex angles? The B word? Bisecting, yes. All right, so let's come back to our notes. So the diagonals, as we noticed, are perpendicular. The vertex angles are bisected by the diagonal connecting them. And the non-vertex angles are congruent. Okay, so in problem 4, angle 1 should be easy. It's angle 1. Notice that it's formed by the intersection of the diagonals. What did I tell you about those diagonals, Grace? Right, angle 1 will be 90 degrees because the diagonals are perpendicular. All right, while we're waiting for my technology to catch up with me. Okay, so angle 1 was 90. What would angle 2 be? What would be the measure of angle 2, Casey? It is 50. Can you give us a thought process just in case it didn't come like that to anyone else? Okay? Uh-huh. Good. Right, and the three angles of a triangle, of course, add up to 180. Okay, so it's not on the screen, but hopefully you heard it. Something's being goofy with my screen. Angle 1 was 90, and angle 2 was 50. Please take a moment within your groups to work through the your turn problem 4.